Okay, so we're going to talk about completing the square made easy if a equals 1. So we'll try and give you a pretty easy breakdown on it. A couple of things you need to know. First, you need to know what a perfect square trinomial is. At this point, you should have learned them. You should be familiar with them. I'm just going to kind of recap for you, but it's going to what makes completing the square real simple. And then, of course, you should have learned kind of vertex form. If you hadn't, this is just a format of position which allows us to know what the vertex is. But the benefit of using this technique, okay, is that it finds the vertex real fast and finds solutions real fast if A is 1. Now, A is 1 is one caveat, but B being even is very helpful. Now, it's not necessary because it's still possible because the calculator is easy to help you with all the work, but it is kind of critical that we have an understanding of how the process works. So let's figure out how we complete the square. First, to complete the square really means we're going to build an actual square. So it's a little tricky. So if I think about like a square, right, it would be like if I have a situation like this, and then this is kind of a typical situation you might see in algebra class where we have this kind of setup. And so they're going to ask you, what do I need to fill this little area to make this an actual square? And of course, there'll be some dimensions provided, like some units provided. So if this length here is x, just so we see, right? If that length here is x, and this is just the standard algebra tiles, well then this, and if it's a square, all the sides are x, which would make this side x, right? And this side x, which makes this side x, which means that this whole distance right here would be x plus 3. And then this whole distance right here would be x plus 3. And why is it a square? Because both sides have the same dimension. But in order for this to be completed, right, I would have to fill in this little section right here with something. And it would be some units. Now, maybe these pieces fit, but then we will learn. So if you've never seen these tiles, you should look kind of at a video that shows algebra tiles, because this will help you understand it. But the area of this squared is x squared, the area of this is just x, and the area of each of these are 1. Okay, so this would be x, 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 x. So these are algebra tile formats, and they do equate to one of these, but we'll connect it all. So how do we do the perfect square trinomial? So if you notice this right here, if I want to find the product of these two, and they are both the exact same, right, I'm going to use an area model technique that we should have learned in a class or somewhere along the way, where I can fill in the box and I get x squared, I get 3x, I get 3x, and I get 9. So this equals x squared plus 6x plus 9, because this and this are both 3x, right? So I'll make these 3x's look like x's. Oh, there, my pencil fell on the floor. I guess I must have a steep hill in my bedroom. But what we can see is that we get x squared plus 6x plus 9, which means that if I was thinking about it, this number right here should be a 9, because that would be a perfect square trinomial. And so what would be over here is this x plus 3 times x plus 3, which equals x plus 3 squared. And the point of completing the square is that we can get to this situation where we simplify it to one binomial that we can square, right? So if we work backwards, we can kind of build the equation. So now we are factoring, and that's what the perfect square trinomial is. We're trying to factor it, and so we need to factor in order to complete the square. So what number really goes in here? Well, it's the b term, which is 6, divided by 2 squared. So this number here in this situation would be, what is 6 divided by 2? squared? Well, that is 3 squared, which is 9. So half of 2, right? The number that's going to go up here is half of 2 squared. Half of 2 is 1, so this is just 1. So my factors are x plus 1 and x plus 1, so this factors to x plus 1 squared. Now, how come the 1? So the half value is this number. Okay, so what I find for the half value goes here. The squared value goes here. So let's try the next one. So half of 4 is 2. Okay, 2 squared is 4, right? So this factors to x plus 2 squared. The half value is here. The squared value goes here. What is the half value of this? Well, we already know. This would be x plus 3 squared. What is half of 8? 4. And then 4 squared, 16. So we put 16 here. So the factored form is x plus 4 times x plus 4, which is x plus 4 squared. You can start to see the pattern. I just cut this in half and square it, and that's the number that goes here. So this would become x plus 5 squared. So why didn't I cut this one in half? Why did I leave this one as an odd number? Because I wanted you just to see that if it's an odd number, that we can still do it. It's just, divided by 2, right? And then I square that, so it's going to be 2.5 squared, which is just 6.25. So this would be 6.25 in this box. So this box is just here as kind of a guide for us to fill in. It just helps us. But that just means that I have this factored, right? Half the number goes here, the squared value goes here. So why is that useful? Because if we recall this technique that you learned for factoring perfect square trinomials, then we can kind of extrapolate it a little bit over to up here. So I noticed that all of these situations, I only had x squared and the x term, right? I only had the, if I'm thinking about it, I only had the ax squared and the bx term on one side, and I moved c to the other side. So I'm going to do that here. Well, I didn't have a c, so I shouldn't say I moved it to the other side. I just didn't have a c, but I do need a c. So I'm going to add a number, right? So half of 12 is 6. So this number is 36. Okay, so what I didn't do over here is these were all expressions, and so we were just trying to find the number that worked. But over here we have an equation. And so now I have to recall that whatever I do to one side, I have to do to the other. And so now I can factor this side to x plus 6 squared, and it equals 25, right? I add these two numbers together. So this is where I have two possible paths. From this moment, there are two paths, right? And the first path, we can find the vertex. So to do that, we just rearrange the equation, right? To find the vertex, rearrange this equation. So we'll pull it over to the side here. So I will just take the 25, and I'm going to move it to the other side by subtracting it on both sides. And so now I have x plus 6 squared minus 25 equals 0. So if I'm just going to draw a line here. If I go back up to this format, vertex form, you hopefully have learned that hk is the vertex, right? So in this format, this is hk. A would be the number in front of the parentheses. Since there's no number, it's 1, and we already know a is 1 if we recall our rules. But h would be negative 6, k would be negative 25. That is the vertex for this problem. So we have the vertex right here. What is the solution? So if we go back to our second path, right, we can find the solution just by, from the same step. Now we found the vertex. Now we find the solutions, right? How do we do that? Well, we just take the square root of both sides. It's not always going to be neat. This is a perfect square, so I set it up this way so it would be easy to follow, but it won't always be this easy, right? And so the square root of 25 is plus or minus 5, so I subtract 6. So I'm left with x equals negative 6 plus or minus 5. So that means negative 6 plus 5 or negative 6 minus 5. So that is negative 1, that is negative 11, and these would be our two solutions. And so if I graphed it, I would have a point at negative 1, negative 11, right? And I would have my points here and here. And then I could go so much further if I really wanted to. Halfway between these two, this is 10 units, half of these two is actually that negative 6, right? That's that negative 6 that we talked about, which is the axis of symmetry, which is always the h value. That is the axis of symmetry, if you don't remember. So this completing the square provides so much cool information. And then, of course, way down here, we would have negative 25 down here. And so our graph would look something like this, right? And it would go up, and eventually it would cross through the y-axis off to the side here. And we know where it crosses, actually, the y-axis, sort of. If I put this 3 over to this side, it's going to cross at positive 11, because then I would have x. Everything would be in standard form if I put 3 over to this side by subtracting it, and it would be equal to 0, and I would know my c term. So that is just completing the square in a nutshell.